Good afternoon, ladies and gentlemen, and welcome to the EGD zone. In today's video, we are looking at a grade 11 interpenetration and development question. And looking at our question, we are given the casting of an incomplete front view and the top view of a cylinder shaped to fit around an equilateral triangular prism. We are given the cylinder and the prism as solids, and the axis of the cylinder and the prism lie in a common vertical plane. You are given the auxiliary view of the cylinder and the position of point A on the drawing sheet. Instructions say you must draw to scale 1:1 the given top view and the front view showing the curve of interpenetration and the right view of the cylinder and the prism. Okay. You must also develop the surface of the triangular prism showing the points of interpenetration. You must also develop the surface of the cylinder using point S as the start position. Show all construction lines, calculation, and fault lines. Okay, as you can see that I have highlighted calculation and fault lines because I have seen that most learners make a mistake of not showing calculation and not showing their fault lines. Alright. So now looking at our question, you can see that we are given the side length of the triangular prism, which is 65, and it is the main pipe, whereas our branch pipe will be the cylinder. Okay, and you can see that we are also given the diameter of the cylinder, which is 50, and we are also given a measurement away from our triangular prism, which is 10 millimeter away. We are also given our measurement from the top, which is 9 millimeter away of where our cylinder will start. Alright, so the one thing that you will need to do is that from A, you will need to construct your vertical line. You construct your vertical line from A so that you can get your C. Alright, and then once you get that vertical construction line, you will need to measure 65 from A until C. You measure 65, and then once you get your point on that vertical line, let me take you through this so that you can be aware of what I did. So if you can see that from point A, angle 60 was used. Okay, this is angle 60. Then also on this side from point C, they used angle 60. So the question is, how did we arrive on angle 60? Because we are not showed angle 60 on our drawing. So you will need to say, whenever you are dealing with polygons, in order for you to know an angle that you are going to use, you'll have to say 360 divided by number of sides. Alright, so in this case I will write 3 because I'm dealing with a polygon of 3 sides, 1, 2, and 3. So 360 divided by 3 gives me 120. Okay, even so, you can see that from your protractor that 60 is underneath 120. Okay, so you can simply just say 120 divided by 2, it will give you 60. Hence, from point C and point A, we'll need to use angle 60. Right, so using angle 60 from point C there, you will get an apex B, and also from point A. Alright, and then now that you have your equilateral triangular prism, you will have to create your XY lines any distance away from your top view. So my vertical XY line, which is on the side, I made it 10 millimeter away from my top view, and then my horizontal XY line, I made it 5 millimeter away. Okay, and then once you have all your points, please don't forget to label. Okay, and then you construct B. So now we will need to construct our center line, and our center line is from apex B. Okay, from apex B. Someone might be asking themselves that how is it that my 45 angle is on this side, because we are needed to construct our right view. So since interpenetration and development falls under first angle, our front view will always be our top view, our right view will be on our left, and our left will be on our right. So hence my 45 is on my left side. Okay, and now I will need to get my height for the equilateral triangle. From XY line is 65. Right. So here it will be B and B, CA, CA. Every time when you are dealing with polygons, you just need to label. And then we must also include this measurement from our top, okay, which is 9 millimeter. Okay, from here until 9. And then this is where our cylinder is going to start. And they said 10 millimeter away from your, just we have it there. Okay, so now in order for us to construct our right view, we will need to go with point A to our 45 angle, point B and point C also. And then as soon as they reaches our 45 angle, we'll have to construct them back to our right view. Okay, and then on this line we have B and B. On this line we have C, C, A and A. And then before we can use our solid lines on our right view, I would like for us to include our cylinder. Okay, because looking from your right hand side, we are going to see the cylinder as a solid line, and then we are also going to see line B as solid, line C and also line A. Okay, so now they give us a diameter of 50, so you can measure. If it is a diameter of 50, meaning radius is half of diameter, which is 25, meaning from the top to our center it will be 25, and then from the center again to our circumference of the circle it will be 25. So allow me to say here on line B, because this is the center, I will have to measure from that 9 we got here on our front view. It will be from that point there. For me to get my horizontal center line, I should measure 25. Okay, so from that 9 to my center is 25. Here it will be my 25. Okay, so now you're gonna take your compass and set it to 25 radius. Then after setting your compass to 25 radius, you come here on your center and then you construct your full circle. Alright, and then that's when now we can include our solid lines. And now we are done with we are not done with our right view. What what you will need to do now is that you will need to divide our circle into 12 equal parts, because every time when we are dealing with a circle, we need to divide it into 12 equal parts. Okay, so using your 30 by 60 is a square. You can divide your circle, or you can use your protract. Any method to divide your circle is allowed. Okay, so now I am going to label S1, 2, until S11. Okay, and now I will need to construct from my cylinder to my front view all the points I have on my circle. Okay, so here it's going to be S, and then on this line we have S1 and S11, S1, 11, and on this line we have S2, 10, and then on this line we have S3, S9, we have S4 and 8, we have S5 and 7, and the last one is S6. Alright, then coming to label our top view, we'll need to construct our points from the front, from the right view to the 45 angle, and when they reach our 45 angle, we construct them back to our top view. Okay. And then now coming to label this side, we can see that this on this line we'll have our S and our S6. Okay, so here we'll have S and S6. Okay, on this line we have 1 and 5, which is S1, 5. Then on this line we have S2, 4, and then we have S3. Okay, and then on this line we have S7, 11, we have S10, 8, and the last one is S9. Right, so now what you will need to do is that you will need to complete our incomplete front view. Okay, so now we will need to check how long is S9 interpenetrating until our triangular pipe, and then we also need to complete it here on our front view. So starting with S, let's start with S. Here's our S on our top view. So let me also make this solid line so you can be able to see. So now starting with S and S6, so we are constructing until where it is interpenetrating to our front view, and look for S and S6, meaning S will be here and this will be S6. Right, and then now moving to 1, and 5, which is going this side. 1 and 5 is interpenetrating until here, and then you construct 1 and 5. You go look for 1 and 5 on your front view. Okay, 1 is here. Where is 5? 5 is here. Okay, and now from your top view you can see that not only 1 and 5 are interpenetrating until there, also 7 and 11. Okay, so on this line you'll have 4 points. How do I mean by that? I mean that looking from this side, you are going to have 7 and 11 here, which is 2 points, and 7 is on the same line with 5 from your front view. Okay, so 7 is going to be visible, and also 11 is going to be visible, meaning 1 and 5 are going to be at the back and are going to be hidden details. So we won't be able to see 1 and 5 coming from this side. And then we need to check that how long is 2 and 4 are interpenetrating. Okay, so coming on our top, we construct 2 and 4, and then you can see that not only 2 and 4 are interpenetrating until here, but also 10 and 8. Okay, so coming from this side, 10 and 8 are going to be visible, which is here is 8 and 10, and behind these 2 points there are those 2 points, which is 2 and 4. Okay, and then the last ones are 3 and 9, and you can also check that this thing repeats itself, because behind 9 there is 3, because coming from this side 9 is going to be visible. Okay, and then now you can complete your curve using your freehand or your flexi curve. And then now you are done with completing your front view. So now we will need to move to developing our surface. Okay, so let's start with our main pipe, which is the triangular prism. Okay, so every time when we are developing our surface, we will need to use our true lengths. Okay, our true lengths, we get them from our front, not our front, our top. Okay, because this is the equilateral triangle. So the true length here will be 65. So from A, B, C, and A again. Okay, let me show you. This is from A with 65, B, C, and A again. And then you need to label all your A, B, C, and A. Okay, and not forgetting that our height is the same, which is 65 also. So 65 there. And now one thing that you need to check is that from A going to B, here on our top view, we come across line S9, S10 and 8, and S11 before we get to B. Okay, so we'll need to take those measurements. From A approaching B, we come across S9. Okay, here's S9. This is A approaching B. We call it S9. And also A approaching B, we come across S10 and 8. Okay, this is S10 and 8. Then also we come across S7 and 11. Okay, so we're just going to do our vertical construction lines and determine our point of interpenetration here on our development. Okay, so coming here, how do we get our points of interpenetration? We can't get them on our top view. We'll need to get them from our front view. Alright, so coming here on S9, our point of interpenetration is from XY line to the center line, which is there, and then 10 and 8 on this line. We are looking for 10 and 8. This is 10 is here, and then 8 is here. Okay, point of interpenetration 8, then also point of interpenetration 10. Moving to S7 and 11, here will be 7, and 11, here's 11. Then here at B, which is now, we have S and S6. Okay, so here at B, we will have 2 points, which is S6 and S. B, S, S, and then B, S6 is here. Right, and then now since we are going to move from B to C, we will need to check which points do we come across before we come to C. Okay, so from B approaching C, we come across S1 and S5 on this line, S2 and S4 on this line, and then also S3. So from B approaching C, we extend the compass until S1 and S5 here. Okay, and then from B approaching C, this is S1 and 5. Then from B approaching C, we extend your compass until S2 and 4. So coming here on development, it will be S2 and 4. And then from B approaching C also, it will be S3. So now we will also need to do a vertical construction lines so that we are able to determine our points of interpenetration. Alright. So now coming to develop our points of interpenetration, S1 and S5, 5 is here, point of interpenetration, and then 1 is there, meaning 7 and 5 are on the same point of interpenetration. So from 7, okay, coming here, this is going to be my point of interpenetration 5 there, then my 1 is there, so I can measure from the top to 1 this distance. Okay, let me show you. On this line you can measure from the top there, and this is your point 1. Then on the top, point 1 is here. And then now on line 2 and 4 from our development, this is line 2, 4. So come here on the front view, this is line 4. Point 4 is here. And then 2 is here. And then the last one is 3 is there. So when you are done, you can connect all your points using freehand. Okay, and now you don't need to forget to show your fold lines here at B. Okay, these are your fold lines. So now we will also need to develop our surface for the cylinder. So now going to the cylinder, there is a certain formula that we use to determine our length of the cylinder. Okay, so we are going to say pi times diameter. Every time when you are dealing with a circle or a cylinder, you always use this formula, or you can use 2 pi radius. Okay, so in this case I want to use this formula. My length, it is going to be pi times diameter. We are given as 50. My length is going to be 157 comma something, comma, let me use my calculator. 157, no, pi times 50 is giving me 157,08, and then using this one, my length is going to be 2 pi radius, then 2 pi. If you are given a diameter 50, our radius is going to be 25. Okay, so 2 pi times 25, it's also giving me 157,08. So coming here with my measuring ruler, I'll have to measure this line here with 157,8. Says 100 is here on 10, 110, 120, 130, 140, 157,8. Yeah, 157,8. No, 156,7,8. Yeah, approaching 158 there. Okay, and then now you also need to create another line here at any angle. Okay, and then you divide this line into 12 equal parts. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 will be there. So we just need to extend this line there. Okay, then the last point is the one that we are going to connect with our length that we got, which is 157. Okay, and then parallel to this line, from all our points we have on this line, we'll have to construct parallel lines to this one. And then now we need to construct your horizontal lines. And then now, not forgetting to label, this is S1, 2, S4, S6, 7, 8, 9, 10, 11, and S again. Alright, and then now, how do we determine our development of the cylinder? So this is our cylinder here. Also here it is our cylinder. We can use either these true lengths or we can use from our front view. Okay, so I want to use my top view here. So coming here, starting at S. So but because this is not only S, is S and S6, this line. So I'm going to come here on S, also on this side, because this is S, and then S6 again. Okay, then this line is 1 and 5. You see, so 1, also 5. Okay, and then you can also see that 7 and 11. 11 is here, 7 is there. Okay, and then now going to 2 and 4. 2 and 4. 2, 4, and also 10 and 8. Okay, line 8, line 10. The last one is 9. 9, not forgetting 3 on this side, and then 3. Okay, once you have all your points, you can quickly join them with your free hand, or you can use your flexi curve. Okay, and then now, not forgetting to show your fold lines. Alright, so that's how you should that's how your drawing should look like. Okay, so please, if you found this video very helpful for you, give it a thumbs up, and please share it with your friends and family. Thank you for taking your time to watch this video.